Okay, let's get started. So today I'm going to finish up the last couple bullet points from last time, and then I'll come back to this outline and talk about sort of today, actual lecture for today. But I just want to jump straight into finishing up what we did last time. I showed you a model last time, this sort of effort cost model of daily labor supply, and showed that it unambiguously predicts that people will have a positive elasticity of labor supply with respect to changes in their daily wage. And then I showed you a bunch of evidence that says that's not actually what we see in the rare case of a market where people actually do choose how many hours to work each day or how much effort to put into their work each day, and where they also have daily fluctuations that are random, but random in a predictable and known way, right? So we looked at evidence from cab drivers in New York and bicycle messengers in Zurich, Switzerland, and found that pretty unambiguously they have a negative elasticity of supply, downward sloping supply curves at the daily level. And then we started very briefly looking at a model of how this might happen, or what might explain this. Okay, so we're going to fall back on reference dependence and loss aversion, not surprisingly. And the basic idea here is that workers have some kind of daily income target, and that up to that target they feel pretty good about. They feel pretty strongly about making money. And then after that they reach their target. It's not that they refuse to work. It's just that earning more money doesn't mean as much to them for that day. Why? We're not going to get into that. The psychology of why that would happen is not our job. Our job is to find out whether or not that model actually can explain the data. Okay, so here's a real simplified version of this. We're just going to take exactly the effort cost model that we use, right, that we sort of borrowed from profit maximizing firms, and we're just going to jam a kink into it. So let's see how that works. Let me just remind you, I mentioned this somewhat shamefacedly last time. There was an error in the handout, but not in the slides last time, which has been corrected in this handout. So last time that was wrong. So please make sure that you, when you're studying for the exam, that you refer to the corrected handout. Okay? So here's what we're going to do. We're going to let K, some constant K, be the daily income target. And we're not going to say anything right now about where it comes from. And now we're going to model sort of people's, we're going to just in quotes their revenue, right, which is really their utility from income. We're not thinking of this in dollar terms strictly, although it plays a similar role to revenue in a profit maximization. And then there's going to be the effort cost, and there's going to be the profit, right? So this is all just dollars. We're going to just model all of that on this axis. And before, what we had was that the revenue was just the wage times the number of hours that they did, because they're spreading their income out over the whole month, right? That it's just a straight line. They're just trying to earn as much money as possible, like a firm would. But here, what we're going to do is we're going to say, well, at first it's that. So let's put K in here. Let's say that K is the income target, and at first people are going to get revenue from income. Sorry, I'm actually going to make that a little bit shallower. Put it like that. And then when they reach K, right? What I'm going to do is there's going to be a kink here. But to help out for the actual wage analysis that we're going to do, I'm going to continue this as a dotted line. Ooh, it's not a line at all. Sorry, let me get it straight. Okay, so nice straight line up to K, and then I'm just going to extend it as a dotted line beyond there. And then it's going to be this kink. Now let me just show you. Let's just rewrite this. What is this? K plus 1/2 times W minus K. Well, WL minus K. WL minus K is any earnings that you get above your income target. Yeah. So the total utility you're going to get for labor if you are above your income target is going to be K utils, so 1 for 1 up to K, and then beyond that, anything above K, you're only going to get a half a util per dollar. Okay. So to see that graphically, let's rewrite that. Right? If we just take, I really wish the screen was lower. If we take 1/2 and distribute it over WL and over K, then essentially we're subtracting 1/2 K from K, so that's just 1/2 K plus 1/2 WL. And so essentially the way we can think about this is, here's 1/2 K here, right? So this is going to be a line that starts off, and I'm going to make it a dotted line up to the kink, and then it's actually their revenue function or their utility function for income beyond the kink, okay? So that's what that looks like. The only real difference between this and what we've done with mugs is that I've kept the vertical axis down here in absolute terms at 0 real hours of labor and 0 real dollars. Right? Before, what I did was I said, no, let's adjust the axes so that the 0 point is at your reference point, so the kink is always there at the origin. You could do that here. You could say, well, let's just model this as maybe they get negative utility from earning below their reference point. But in that case, it's awkward. It's just this is an easier way to think about it, particularly when we add the effort cost function to this diagram. So is that clear how I got that? This is called a piecewise function. And you've come across this kind of thing a little bit in the past. If you did anything 100A with kink budget constraints, piecewise functions come up somewhere else in 100A, and I can't remember off the top of my head where. But doing optimization with a piecewise function like this is tricky, and that's what a lot of the problem set is about, is how to do optimization when you have a piecewise, in this case, kinked function. And hopefully the steps in there, the problem set is heavily larded with hints. Hopefully those hints will be enough, and if they're not, just post questions on the forum. I'm going to show you graphically how this works. So to complete the model, let's add in the effort cost function, right, which is some C of L, where it's upward sloping, C prime is greater than 0, and it's also increasingly upward sloping, C double prime is 0. So what we had last time, I want to make sure I draw this in a way that's going to be helpful, is something like that. Okay? So that's C of L, and then this is our revenue function, if you want. And we've already said the profit is just the distance between them, right? Revenue minus cost. Okay. Now, last time what we saw was that if you maximize this, if you didn't have the kink, then you just could do some mathematical optimization, and the profit maximizing condition, profit in quotes, or utility maximizing condition, was that the slope of the revenue function should be the same as the slope of the cost function, remember? And that was going to tell you exactly where the distance between the two was greatest, which is not surprising, and it's exactly the way this model works when it's applied to firm profit maximization. But here it's a little tricky, because the revenue function has two different slopes. And so what we have to do, and this is true anytime you have a piecewise maximization process, is you have to solve the maximization problem for the first piece, and then check to see whether the solution is actually on that first piece. And then if it isn't, you have to go on and solve the maximization problem for the second piece, and see whether that solution is actually on that second piece. And if it is, great, you've got whichever one that is true for, you've got a solution, and then we'll talk about what happens if it's not true for either of them. Okay? So for this case, for example, where is the place, and this is why I drew these dotted extensions, where is the place where this curve, the slope of this curve, is the same as the slope of this line? Well, it looks to me like it's kind of somewhere about in here, yeah? Okay? So according to that tangency rule for profit maximization, this would be the place to the number of hours to work. The problem is that if you're working that many hours, you're past your peak. This is no longer your actual revenue function. So the way this is true anytime you're solving problems with piecewise functions is you find a solution mathematically, then you check, is it in the right piece? No, it's not. So you scrap that. That can't be a solution. You just reject it. Then you move on to the second piece. Where's this line tangent to this curve? Well, it looks like it's going to be somewhere way down here, right? So is that L star? No, because it's not on this piece of the revenue function. Okay, so you reject that solution as well. And you can just see graphically. It's really obvious once you've rejected both of those solutions what the solution must be. The place where profit is maximized is right in between these two pieces at the kink. Okay? And that doesn't necessarily, that's because of the way I chose to draw it. That's because of the specific W that is implied by this function. If you made W really, really small or really, really big, you might not necessarily wind up at the kink. Okay? And that's you're going to see that in the problem set. But in the meantime, I better get, you know what? I'm sorry. I'm going to just, I want K to be actually at the kink. Sorry about that. I'm not. I actually, I spent a year pursuing trying to become a major in art, and I had to abandon that. So K is somewhere in there. Now, what happens when the wage increases? Okay, let's say the wage increases a little bit, so that W times L is going to be a steeper line, and it's going to so the revenue function is going to be a little bit steeper up to the kink. I still haven't got K in the right place. I want it to be exactly the same. And then at the kink, it'll go from there. It'll be steeper. Sorry, it'll be steeper than before, but not as steep as here. And the point is that the kink is at the same place vertically, right? The kink is still at K. And if we go through this thing, we're going to see, well, the point of tangency here is even further out, and the point of tangency on this section is probably still somewhere about in there. So we still don't have a solution that's on either of these segments of the revenue function. We're still at the kink. Profit maximizing solution is still at the kink. So the profit maximizing labor here is L star, and then if we raise the wage, right, if we want to call that L star prime maybe, then what's happened is that people are working less. And the reason why is because they get to their kink faster. They get to their target income faster with a higher wage. And it's not that they have no impetus to work beyond that. It's just that suddenly the value of money goes down for them and to a point that is less than the effort cost. Okay? Now, intuitively, you can probably imagine what would happen if I just cranked the wage way, way up. Right, is that this part of the revenue function would eventually become steep enough to make you want to keep working. And that's what you're going to solve for in the problem set. But in the meantime, there's going to be a segment here where when the wage goes up, people's willingness to work goes down. Which is a lot like the backward bending labor supply curve that we got with the income effect, but for a very different reason. Yes, tell me your name again. Andrew. What determines K for each person? Tell me what you would guess. Andrew's question was what determines K for each person? Where does this income target come from? Do you have a guess?
It could be a myriad of factors. So I don't know how this would be able to determine.
It could be a myriad of factors. Not an economist's favorite word. Does anybody else have any ideas? I'm not saying no to that answer yet. Yeah.
So like the biggest factor is rent and like food.
Okay, rent and food.
Like your biggest expenditures, you want to at least like make an income.
Tell me your name. Josh. So Josh is saying rent and food and other big expenditures. So in some sense, what is your minimum necessary income to sort of like pay your bills and get by? Okay. So yeah, that seems like it. I would believe that. If a taxi driver told me I work until I got enough to get by and I stop, I would believe that. Yeah.
Working enough so that you don't go above the next tax bracket.
Aha, working enough so that you don't go above the next tax bracket. So there's a different kink in your life, right? There's a kink in the tax code. And so you're going to work up to that kink. For some reason, you're monthly, because of the kink in the tax code, you've made a monthly labor-leisure trade-off decision that gets your monthly income right to that kink. But why would you still not take advantage of the fact that the wage is higher to work harder on a high wage day and get to that monthly kink sooner? Basically, what you're saying is, let me take my goal, my monthly goal, which is based on a kink in the tax code, and just divide it by the number of days in a month. Well, why would I do that? Indeed, why would I do what Josh is saying? If I'm trying to make my minimum amount for the month, why would I then take that and divide it by the number of days in a month? Why would I still not want to take advantage of the higher wage on the high wage days? So I feel like there's two dimensions to this puzzle, right? One is we've already got two potential candidates, and there's all kinds of others. Right? Maybe your income target is the guy next door. Maybe your income target is, I don't know, maybe you've got a savings goal because your girlfriend or boyfriend is going to leave you. You're buying a nice new coat, and so you're trying to save up for that. Whatever, right? So that's the myriad. That's the swamp that economists don't want to be in. But beyond that, we have this larger goal. If your goal involves a time dimension that goes beyond the end of the shift, you should still be taking advantage of the higher wage on the high wage days. And I say should advisedly because what you should do is you got to do what you do because I mean, right? Should is not a particularly helpful word when you're trying to predict people's actual behavior, but it's a puzzle. The answer to your question, Andrew, is it's a puzzle. Okay, and it's a puzzle we're going to spend most of today talking about. Okay, so what happens if labor supplies wage increases? We've already answered that question. At least within a certain range of wage increases, you'll get a negative elasticity of daily labor supply. Yes. Yep, you did. You just answered your question. And tell me your name? Diana. Yes, you did. And not only that, you just answered part, I think, C of the problem set. Okay, now, just briefly, I apologize for my sniffing. I have a sinus problem, and I got it operated on about 10 years ago, and the operation didn't solve the problem, so sometimes I sniff far more than is actually polite. Okay, I want to throw in, because I really find this kind of thing really valuable and interesting, and I'm not sure that all economists do, but I think it's worth commenting on. We talked about the Kammerer et al. Taxi driver study, and we talked about the Fehrengoethe bicycle messenger study, and both of them have kind of, I think, very clever and interesting, and at least to a normal person, that is to say not an economist, potentially quite compelling, additional ways of poking into this question, right, of how do people make their daily labor supply decision. So here's Fehrengoethe. Now let me just show you what's going on with this graph. Can you see the gray line? Can you see both lines on that graph? Okay, so here's what's going on. We have, this is revenue. This is the revenue response, which is their proxy for effort, right? So this is revenue per shift, CHF here, Swiss francs. And this is frequency. So this is an empirical probability distribution, okay, a frequency distribution. How many people were at each level of revenue per shift? So what you see is that for the control group, which is gray, right, they maxed out. The largest, the sort of modal effort level or modal revenue is right in here at I don't know what that is, 200, somewhere around 250. And the mode for the treatment group, who got a 25% increase in their commission, is the same. But the whole rest of the distribution is shifted to the left, which reflects the fact that on average the effort level for the treatment group was lower, right, which we talked about last time. So this distribution gives you a sort of graphic way of seeing that, except that, I mean, the mode is still the same, but the whole of the distribution other than the mode is shifted over, pretty much, right? That's why the mean is different. Then they did something really interesting, which is that they then went after the fact. I think it was after the fact. It doesn't really matter whether it was before. I think it does matter, actually, and it's important that it was after the fact. And they gave all of these bicycle messengers, both in the treated and controlled groups, this experimental task that is used classically in behavioral economics to try to ascertain whether or not people have loss aversion, right? Whether they are subject to the down effect. Now, it wasn't the mugs and candy bars experiment. It was a different experiment based on trade-offs between different lotteries, and which we're going to start talking about on Tuesday. But it's a very, very classic behavioral device, experimental device used to sort of categorize people into those who have an indication of loss aversion and those who have no indication of loss aversion. So this graph is just the people in the treated group. So they've divided the treated group into people who exhibit loss aversion in this experimental task and people who don't. Okay? And what you find is that the people who exhibit loss aversion are the ones whose effort level was shifted down, went down. And the people who, the gray line, is the people who had no indication of loss aversion in this experimental task, and their effort level has not gone down relative to the control group. Okay? So this is additional suggestive evidence that says, hey, look, the psychological story that we're telling here seems more compelling when we actually go and use a sort of psychological experimental test to poke into it a little bit more carefully. It's not just that our model fits the data better, okay, but that we can actually distinguish these people psychologically. Now, what I would want to do in this experiment is to give them a whole bunch of other tests. Okay? Are they also excessively impatient? Are they smarter or dumber? I would want to know a lot of other things about their psychology and see what else maps into their effort level response. But they only did the test that actually tells the story they want to tell. That's not the way. I would have liked to have seen a little bit more robust battery of psychological tests, but I still find it quite compelling. Here's another thing from Kammerer et al. From the taxi driver experiment, or not experiment rather, but observational study. They went, and I think this is way, way more valuable than most economists hate surveys. They're like, oh, people won't tell the truth on a survey. Surveys are for sociologists. That's qualitative research. We do quantitative research. But my response to that is, well, then I guess you would reject almost all of labor economics, which is mostly based on the consumer population survey and the census, right? Which are surveys. So there are holes in that argument, but it's a nice, snarky thing to say. And so I think it's really valuable to go out and just do a survey. Maybe it doesn't prove anything, but it can really sort of reassure you that you're on the right track. So they went out and they talked not to the drivers, but the fleet managers, right, who know these drivers. Maybe they were drivers in the past, and they know these drivers day in and day out. And they just asked them, how do drivers decide on their hours? And they gave three different multiple choice answers. And the modal answer, the one that most of these fleet drivers said, was just drive until they make a certain amount of money. Okay? Now, there were other answers. A close runner-up for the most common answer was just work the same number of hours every day. Only one of the fleet managers that they surveyed said work more on high-wage days. So, again, it doesn't prove anything, but it suggests that we're on the right track. Yeah? Okay, enough about that. No, not quite enough, sorry. More to say about that. Why should we care? Why should we care about, bicycle messages in Zurich? I'm sure their mothers love them, but really, we have like a Euro debt crisis going on, we have a stagnant potential non-recovery going on. Why do we care about this? Behavioral economists care about it primarily for theoretical reasons. So we're talking about positive first, not normative. Our theories make predictions about lots and lots and lots of situations that we can never test. So to find a real-world market that has the properties that make it possible for us to do a real experimental test, or even a really well-done observational test like the taxi drivers, is rare. So we take it where we can get it. Economics is, outside of finance, economics is a data-starved science. So we take it where we can get it. So it matters a lot for theory, for testing theory. So second of all, a lot of times you look at this, well, maybe we don't care about bicycle messages and taxi drivers, but we do care a lot about incentives. Okay, so this tells us something, this might tell us something, if it's generalizable, about how lots of people respond to incentives, and employers frequently have a need to incentivize additional effort on a short-term basis. And knowing that if their employees are using income targeting, it may backfire, that the incentives may backfire, is in fact important for employers, public and private employers. And in general, behavioral economics has a lot to say about the design of incentive schemes. Okay. What about normative issues? What about what we can say about what's right and what's wrong or what's good and what's bad? Okay, so here's a little bit of both of these studies. Take another lecture step that I think is really interesting. Kammerer et al. Worked out the daily labor supply elasticity for each individual driver in their data set. Right? We saw it on the average elasticity, but then they worked it out for each driver. And they identified the drivers who had the negative elasticity, they're the income targeting drivers, and then the drivers who didn't, who maybe are following the standard model. And what they found is if they took the people who exhibited income targeting, and then using a computer simulation, a very simple, I'm sure, to some Excel spreadsheet, they figured out, well, what would those people have earned if they had just worked steady hours at their own average number of hours? And the answer is that on average, their income would have gone up by 7.8%. And then they said, well, what if they had done what we would have expected them to do, which is to have a positive labor supply elasticity of 1, right? So that for a 10% increase in the wage, they would increase their work hours by 10%. And the answer is that they would have increased their income by 15.6%. Nobody's stopping them from doing that. That is essentially the equivalent, this is the way economists think, that's essentially the equivalent of declining a 15% raise. Okay, so if you can find examples of people in large numbers declining voluntarily a 15% wage increase, do let me know, because that's publishable. Fair and Gotha did something similar. They just showed that for the folks who had decreased their work effort with the 25% wage increase, if they had not done so, if they just kept working the way they had before, they would have increased their income by approximately a third. Okay, so that's leaving a lot of money on the table. So then we want to ask the question, normatively, in what sense are these workers maximizing their own well-being? It seems kind of self-defeating what they're doing. Now, it could be that this income targeting strategy is actually better for them. For example, and somebody, I think it was Palace, sort of pointed out last time, well, maybe it's not that easy to figure out how, maybe it's not so obvious. We have to write down this complicated mathematical model to demonstrate that it's in their best interest to work more on it. Maybe they just don't have it figured out. Or maybe they have a general idea that they should work more on high wage days, but they don't know how much more. And so there's a cognitive overload issue here, and they just say, give me an easy